day, everyone. Welcome to our discussion of your Module 3 entitled, It Makes Up Everything. Does it matter? In your Module 3, we are expected to learn the following. Number 1, differentiate elements from compounds based on their composition from the given chemical name, symbols, and formula. Number 2, briefly describe the history and basis of naming elements. In your past grade level, you have learned about matter. Matter is anything that occupies space and has mass. This means that everything around us is matter, regardless of shape and size. From the tiny atom to the vast solar system, matter is so diverse that we need to classify it. Matter can be classified into two ways, based on physical and chemical properties. In the physical classification, matter is classified into three states of matter, namely the solid state, liquid state, and gaseous state. Chemically, matter is classified into two groups, the pure substance and impure substance, or what we call the mixtures. In your Module 3, we will be discussing about the pure substances. Pure substance is a form of matter that cannot be separated into its components by any physical means. It is made up of only one type of atom or molecule and have a definite and unchanging composition. There are two types of pure substances, namely elements and compounds.
Number 1, elements.
An element is the simplified occur naturally on Earth, and the rest are synthetically prepared in a laboratory. This is an example of a periodic table of elements. As you can see, there are boxes with letters and numbers inside. Each box corresponds to an element. Therefore, if you are going to count the boxes here, you will find 118 boxes, which means that there are 118 known elements as of today. Let's study the box for hydrogen from the given periodic table. There are some information that we can get from each box. We can see the atomic number that corresponds to the number of protons found in the nucleus of every atom of that element. The atomic number uniquely identifies a chemical element. We can also see the element symbol, the element's name, and lastly, the atomic mass. The atomic mass is the mass of an atom. Dmitri Mendeleev was the scientist who first created a periodic table of elements.
Names of elements.
The names of the elements have originated from a variety of sources. By international agreement, the names of chemical elements have been standardized for use throughout the world. IUPAC, or the International Union of Pure and Applied Chemistry, approves that names of elements. The IUPAC guidelines in naming elements can be: number 1, based on the discoverer or scientist, such as Einsteinium, named after Albert Einstein; Mendelevium, named after Dmitry Mendeleev; Copernicium, named after Nicholas Copernicus. Number 2, mythological figures such as thorium, named after Thor, the Norse god of thunder; Tantalum, named after King Tantalus of Greek mythology, the son of Jupiter; and helium, named after Helios, the sun god. Number 3, astronomical objects such as Mercury, named after the planet Mercury; plutonium after Pluto; and palladium, named after the asteroid Pallas. Number 4, mineral or similar substance. And examples of these are lithium, from the Greek word lithos, meaning stone; calcium, from Latin word calx, means chalk; and potassium, derived from Arabic word alquali, meaning the ash. Number 5, property of the element, such as zirconium, from Arabic word sargum, meaning gold color; astatine, from Greek word astatos, meaning unstable; and phosphorus, from the Greek words phos and pyr, meaning light-bearing, since white phosphorus emits light in the dark. And number 6, based on places or geographical region. Examples of these are americium, named after America; californium, after California; and germanium, after Germany.
Elements chemical symbols.
Each element has been given a chemical symbol. This symbol is a shorthand in writing these elements. So, how are these elements given a symbol? Number 1, based on the first letter of its name. Examples are H, hydrogen; B, boron; C, carbon; N, nitrogen; O, oxygen; F, fluorine; P, phosphorus; and S, sulfur. Number 2, based on the first and second letter of its name. Examples of these are helium, He; lithium, Li; beryllium, Be; neon, Ne; aluminum, Al; silicon, Si; argon, Ar; and calcium, Ca. Number 3, based on the first letter and other letter from the element's name. Examples are magnesium, Mg; chlorine, Cl; chromium, Cr; manganese, Mn; zinc, Zn; neodymium, Nd; radon, Rn; and californium, Cf. Number 4, based on its Latin or Greek names. Examples are sodium, Na, from Latin word natrium; potassium, K, from kalium; iron, Fe, from ferrum; copper, Cu, from cuprum; silver, Ag, from argentum; tin, Sn, from stannum; antimony, Sb, from stibium; gold, Au, from aurum; lead, Pb, from plumbum; mercury, Hg, from hydrargyrum; and tungsten W from Wolfram.
Rules in writing the element's chemical symbols.
The first letter of the element symbol should be written in a capital letter. If the symbol has a second letter, the second letter should be written in small letter. So if you were asked to write the symbol for cobalt, it should be capital letter C and small letter O. Remember, in writing an element's chemical symbol, it should be capital letter plus small letter.
Number 2, compounds.
Next type of your substance is a compound. Compound is composed of two or more types of atoms, which is formed when elements combine chemically that they cannot be separated by any physical means, but can be separated by chemical reactions. We can make endless numbers of compounds by combining different ratios of different elements. A compound is composed of molecules, which are two or more types of atoms that are chemically joined together. An example of this is a water molecule. Water molecule is made up of one oxygen atom, represented by the red sphere, and two hydrogen atoms, the white spheres. When two or more atoms of different elements are combined, the compound formed will never be the same compared to the properties of the original elements. Example, water is formed when two atoms of hydrogen and one atom of oxygen are combined. Hydrogen is an odorless, colorless, flammable gas. Oxygen is an odorless, colorless gas. When hydrogen and oxygen combine, the compound formed, which is water, is a liquid, which is different from both the hydrogen and oxygen.
Chemical formula.
Compound is represented by a chemical formula. The chemical formula for water is H2O. H stands for hydrogen, O stands for oxygen, and the number 2 after hydrogen denotes the number of hydrogen atoms combined with oxygen. The water molecules has 3 atoms, 2 atoms of hydrogen and 1 atom of oxygen. Other examples of compounds and their formula are number 1, sugar, 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Baking soda, 1 atom of sodium, 1 atom of hydrogen, an atom of carbon, and 3 atoms of oxygen. Number 3, salt, 1 atom of sodium and 1 atom of chlorine. Number 4, carbon monoxide, 1 atom of carbon and 1 atom of oxygen. And carbon dioxide, 1 atom of carbon and 2 atoms of oxygen.
Comparison between elements and compounds.
We will be using a Venn diagram to show the similarities and differences between elements and compounds. The green circle stands for the characteristics of an element, while the blue circle is for the characteristics of compound. While the area where the two circles overlap will be for the similarities between the two. So what are the differences between elements and compounds? Number 1, elements are composed of only one type of atom, while the compounds are composed of 2 or more types of atoms, which are called molecules. Number 2, elements cannot be broken down further, while compounds can be broken down by chemical reactions. Number 3, elements are limited. There are only 118 discovered elements as of today, but we can form endless numbers of compounds by combining different elements. And number 4, elements are represented by chemical symbols, while compounds are represented by chemical formula. So what is the similarity between the two? Yes, they are both pure substances. Again, pure substance is a form of matter that cannot be separated into its component by any physical means. It is made up of only one type of atom or molecule and have a definite and unchanging composition. Now that we were done with the discussion about pure substances, you can now proceed to answering of your module.
If you have questions regarding your module, contact your teacher right away. Thank you.